Just added one more thing to it.
Shelby, will you grab the lights, please? Thank you. That's your job from now on. Nick, put your computer away, please. John, put your computer away, please. Okay. I believe this is 4.9 is the correct section. 4.9. So we have 3 more sections. 2 more sections, I believe. So the Unit 4 tests is probably going to be the Tuesday, not the Tuesday next week, but the Tuesday after. So probably a week from Tuesday is the tentative plan. Now next week we have I-STEP, Tuesday and Wednesday. So I'm not going to see you Tuesday, but I'll see you Wednesday. So that's going to throw a little wrench in it. But for the most part, we're finishing up. We have 2 more units to do, so we should be fine. So what we're looking at today is we're still going to continue talking about lines, but we are talking about 2 special types of lines. We're talking about parallel, spelled that wrong already, good start, parallel and perpendicular lines. Now, you talked about them some in middle school, so this will be a little bit of review. So parallel and perpendicular lines. So we're still going to apply what we talked about earlier, slope, intercept, blah, blah, blah. But we're going to add that to parallel, what we already know about parallel and perpendicular lines. So what do we already know? What does parallel mean? They never
cross. So parallel lines are lines that never intersect. So some of this stuff you already know. It's Friday. Sorry. Lines that never intersect. Okay, you know that already. Parallel lines are lines that are never intersect. So, what we're going to add today is we're going to go one step further. If I have 2 parallel lines like over here on the side, algebraically, how do we know if 2 lines are parallel? We're going to apply what we know about parallel lines with what we know about slope. If these 2 lines never touch, what do I know about their slope? What is parallel slope? That doesn't tell me anything about their slope. Slope is a number, so we need to compare. These have parallel line. If they're straight across horizontal, the slope is 0. These have a slope of 0. But if I have parallel lines going like this, or like this, what do I know about the slope? They're never crossed, but what does that tell me about the slope? They are the same. We'll get to negative, positive in a second. But algebraically, they have the same slope. Which makes sense, because they have to have the same slope because they're never going to intersect. So remember what we talked about slope. Slope is the steepness of the line. They have to have the same steepness in order for them not to intersect. If they don't have the same steepness, then eventually they're going to kind of run into each other. So since they never intersect, they have the same steepness, they have the same slope. Perpendicular lines, here's an example down here. Perpendicular lines, what do you already know about perpendicular lines? Intersect, a little more specific, at a 90-degree angle. So intersect at a 90-degree angle. You already know that. So we're taking stuff we already know from middle school or last semester. We'll just close your computer all the way, please. Okay. You're going to have... I know, I was answering it. You're going to have... Is it always 90-degree angle? For this class, yes. As you get into other math, like geometry, it might have a little different definition. But for most part, yes. No, perpendicular lines are, for basic definition, always going to be 90-degree angle. Okay, now, this is going to look a little differently. Are perpendicular lines going to have the same slope? No, because they intersect. So obviously, if I have lines like this or like this, they don't have the same slope. Because if they have the same slope, they won't intersect. They'd have the same steepness. These lines do not have the same steepness. They intersect. So, what we know, this is not perpendicular actually, so if we have something like this, that would be more perpendicular, 90-degree angle, but they do not have the same slope. What they have is they have negative they have negative reciprocal. It's a big math word. We'll talk about what that means in a second. Negative reciprocal slopes. So perpendicular lines are a little trickier. They do not have the same slope. They intersect at a 90-degree angle. So they have negative reciprocal slopes. What that means, the word reciprocal, what are negative reciprocals? Okay, the word reciprocal, real quick, all that is, that's a fancy math word that just means flipped. So when I want the reciprocal of something, you're going to take the number and flip it. And if I want the negative reciprocal, you just put a negative in front. If it's already a negative, that will turn it positive, and you flip the fraction or flip the number. So if I look at some examples of a negative reciprocal, what is the negative reciprocal of 3/4? 4/3, but it's the negative, so negative 4/3. So the reciprocal means flip it, the negative means you change the sign, basically. So this is a positive 3/4, it's going to make it a negative 4/3. Now let's look at number 2. What is the negative reciprocal of 2? Well,
1 over 2.
let's think about the whole number. Whole number 2 can be written over 1. So the reciprocal of any whole number is 1 over the number. So 1/2, and it's the negative reciprocal, so negative 1/2. So just because reciprocal is a word that you're not super familiar with, it's not hard to do. Let's look at 3. Negative 7/8. What's the reciprocal? 8/7. It is the negative, so negative of the negative, it makes it a positive 8/7. Let's look at 5. Let's look at 0. This one's a little tricky. We could write it as 0/1 if we want to. Any whole number I can write over 1. What's the reciprocal? 1/0, and it's a negative technically. But what have I told you about earlier? Anything divided by 0 is what? Nope. 0 on the bottom is what? Undefined. So this one's a little trickier because if you flip 0, it puts it on the bottom, but if it's zeros on the denominator, then it's undefined. So the reciprocal of 0 is undefined. So that one's kind of tricky. Okay, now let's look at the next one. We're going to do a couple of these, and then I'll give you time to start the homework. So I want to determine if a segment AB and CD are parallel, perpendicular, or neither. So when I talk about a segment, all I mean is a line segment. So something like that, that's a segment. You'll look more into it when you get to geometry. But a segment is just basically a line with 2 ending points. So if I want to know if the segments are parallel, perpendicular, or neither. So AB, segment AB is formed by the ordered pair -2, 3 and 2, 6. And then segment CD is formed by -1, 0 and 3, 3. Basically, I give you 2 lines, AB and CD. Now, I want to know if they're parallel, perpendicular, or neither. So how do I know? How can I figure out if the lines are parallel, perpendicular, or neither? You could make a graph, but I don't have graph paper, so you might not get an super accurate graph. So without graphing it,
Y minus 1.
what's that going to find me? So you're doing the slope. So what we're going to look at is we're going to find the slope of each, and you can actually just kind of split it down the middle if you want to. So we're going to find the slope of each line segment. Now, what would be the point of finding the slope of each line segment? Why would that be helpful?
So that way you don't have to plot it.
Well, we don't want to graph it because that's going to get messy.
So that way you don't have to graph it.
Right. But what does the slope tell me? How can the topes tell me if they're parallel or perpendicular? We just wrote this up right at the top. How can the slopes tell me if they are parallel or perpendicular? If they're the same, they're parallel. If they are negative reciprocal, they're perpendicular. And if you don't see either of those patterns, then they are neither. Michael, keep your head up, please. Okay, so let's look at finding the slope of AB. You've done this process numerous times. We're just doing it twice. So M equals, if I look at AB, it's y2 minus y1. So 6.
Or y
Just a second, Sheldon. 6 minus 3 over your second x minus your first x. 2 minus negative 2. You have done this process before, so that's why I think today should go pretty easy. We're just doing it twice. 6 over 3. 2 minus negative 2 plus plus, so 4. So the slope of the line AB is 3/4. So now we're going to look at the slope of CD. So slope of CD, second y minus the first y, 3 minus 0, over second x minus the first x, 3 minus negative 1. 3 minus 0, 3. 3 minus negative 1, 4, plus plus, so that is 3/4. They are both the same slope, so they are parallel. Now, real quick, just so I can show you some symbol. A symbol you can use for parallel. If you don't want to write out parallel, you can use the symbol of two lines like this. So those two lines that are straight up and down, that's the symbol for parallel. So if you want to put it up here where we did parallel lines, this is the symbol you can use. Two straight lines up and down. So instead of writing it out, you don't have to use the symbol, but instead of writing it out, you can just use those two lines up and down. Okay, let's look at another example. Let's look at 4 real quick. Let's look at 4. So for 4, I have A, B, and CD. So let's find the slope of each one. We're going to find the slope of AB.
Do we have to write that, or can we just do our thing?
I want you to write down what I'm writing down. If you do it on your own and you can check your answer, it's fine. But I want you to have something down.
Can we just write, like, on the homework, can we just write the y minus, or m equals?
Yeah, you don't have to put m of AB, m of CD. I'm just writing it here so when you go back and look, you see where I'm getting those numbers out. Because it always confused me as a math student when I didn't know where I pulled stuff from. So let's find the slope of AB. So the second y minus the first y, 4 minus 3, over the second x, negative 1 minus 2. So I'm looking at number 4. We're looking at AB. Second y, 4 minus the first y, 3, over the second x, negative 1 minus the first x, negative 2, so minus 2. That will give you 4 minus 3 is 1 over negative 1 minus 2, negative 3, so negative 1/3. So the slope of AB is negative 1/3. Slope of CD, we've done this before. I think this stuff should go pretty well. We're just doing it twice. 6 minus 3 over negative 4 minus negative 5. Check your double negative. It's negative 4 minus the negative 5. So let's look. 6 minus 3. 3. Okay, negative 4 minus negative 5 becomes negative 4 plus 5, which is 1. 3 over 1? 3. 3 over 1 is 3. So, as I look at this, are these lines parallel? No. Are they negative reciprocals? Yes, so they are perpendicular. Now, here's the symbol for perpendicular. It's going to look with the line, I don't know, like an upside down T. So that kind of symbolizes that there's two lines that make a 90-degree angle. So that's the symbol for perpendicular. So you can use the symbol if you want to. That saves you from having to write a little bit. Okay.
Okay, let's do this.
Let's go ahead and that works. So if you get two numbers that are not the same, I'm still talking, guys. If you get two numbers that are not the same and are not negative reciprocals, then they are neither.
I'm going to do number 6. No.
No, we're going to start homework.
Can I go to the bathroom?
Just a second.
You could give me $1 million.
I know.